Hey everybody, so we're going to look at this new problem-solving example today, and it's about some planets in a solar system, and we want to be able to take the coordinates of the coordinates of the planets, their mass, and figure out where the center of gravity is, or the center of mass of the solar system. All right, so um, this is kind of a complex problem, so we're going to practice our problem solving that we've been working at all along. Remember, we're using that input processing output model of problem solving. We're looking at breaking the problem into kind of manageable pieces and coding it kind of piece by piece at a time. And since we just learned about functions, we're going to start writing these more complex problems using different modules or different functions. So we have to kind of plan all of this out and kind of see what happens here. So let's look at what else we're given in this problem and see if we can kind of figure out a good strategy to use. So I think maybe the first place to start would be to let's get the information in from the keyboard or deal with the input. So what is happening is the user is going to tell us how many planets are in the solar system. So that's pretty straightforward. We can read that data in and we'll store it in a variable. And then it's going to ask us for the information about all of the planets. So this looks like it's probably going to need to be in some type of loop that executes the same number of times as the number entered by the keyboard, the number entered by the user there. And then since it's all entered on one line, that makes our life a tiny bit more complicated when we do when we do an input statement, it's going to read all of this data all at once. So we can read that in, but then we're going to have to split that string based on where the commas are. And then we'll have to store each one of those things into a variable. So I'm guessing this is probably a good use of a list here because we're going to need to store a whole bunch of different data and then manipulate it somehow afterwards. So it might be better just to read everything into a list. So it looks like I'm going to need 4 lists. I'm going to need a list for the mass, the x coordinate, the y coordinate, and the z coordinate. So why don't we start with that? Kind of we have a good plan there, and we're going to keep in mind that we're going to be using functions for all of this. So I'm going to start by writing a main function, and then we'll work on maybe the processing part over here. What other functions we might need to write in order to make that work. Okay, so let's create our main program here. And all I'm going to do is just get the data in from the keyboard. So let's start with get the number of planets in the solar system. So maybe we'll call that num planets. That's going to be an integer. You can't have a floating point. So please enter the number of planets. Okay, that's no problem. And then I said we are going to need a loop to read in that correct number from the keyboard. So I'll use a for loop because it's just a counted loop. It's easy. Okay, start at 0 and go to num planets. And then inside that, we need to get the planet info. Okay, so maybe we'll call it planet. And that's going to be a string, remember, so as it's read in all on one line from the keyboard. So M, X, Y, and Z was the format that we wanted. Okay. So again, remember, we're trying to program and test things in chunks. So I think that would, and I could maybe print that out just to make sure that I have it correctly here, just while we test, and I'll get rid of that after. All right, so let's run this and see what happens. I suppose I should probably call that function, though. Okay. and see what happens. There we go. So enter the number of planets. So 3 planets, and what was the data that we were going to use? So it was what, 50, 20, 60, 100. Okay, so it's grabbing it as a string. That's not a surprise. So you could continue that if you wanted to, and it should work. 60, 80, 40, and 55. Okay. Anyways, that's the 3 data. My program stops. Okay. So I'm getting the data, at least in from the keyboard. Okay. But it is in a string, and it's not separate, so I can't manipulate it. So I've got to go ahead and split that string based on a comma delimiter. So we'll split the data into its lists. Okay. So we'll create the separated array. So planet data equals planet dot split. Okay, based on the comma delimiter. Okay, so that would make it at least into a list when we did this. And I'll test it again. Print planet data, just to make sure. I'm only going to do 1 planet at a time here, so we can 50, 20, 30, 40. Oops, what did I do? Planet. Okay. Try again. 30, 20, 50, 60. Okay, so now I have it in into my array. Okay, it's still a string, so I'll need to convert it into numbers after. But what I was planning on doing was storing all of that data in a list, and I need 4 lists. So the first number is the mass, the second one is the x-coordinate, third one is the y-coordinate, and the fourth one is the z-coordinate. So I have to append these to a list, so I'm going to need some empty lists here. So for m, x, y, and z. Okay. And now that I've split the data, I can assign them to their own list. So m.append, and we will convert that planet data. And remember, the first one in the list is the m, so it would be planet data at 0 would be the index of that list. Okay, so that should grab the m values, and then I can do the same thing for the x, y, and z. So x, y, and z, but now the x value is the second one in the list, y is the third one in the list, and z is the fourth one in the list. Okay, so, and if I want to test that, I can do that after my loop, and we can print the we'll print all the lists just to make sure that it is working correctly. All right, so if you're thinking problem solving, I do a lot of testing. I like to print data out after I do different steps just to make sure I'm doing everything right. I don't want to go ahead and try to write some more code if my data isn't being stored correctly. Okay. So maybe we'll just do 2. So 30, 40, 50, 60. Oh, what did I do it again? 3, not 4. Try again. 50, 60, 70, 80, 90, 100, doesn't matter. Okay, so there are my 2 masses. There's my 2 x-coordinates, 40 and 80. My 2 y-coordinates are 50 and 90, and my 2 z-coordinates are 60 and 100. Okay, so I have the data in the list the way I want them to be. Okay, and now I can concentrate on actually figuring out how to solve the problem based on this information. Okay, so now that we have the data in there, we need to figure out how to find these x, y, and z coordinates. So I got to look at this picture a little more closely here and see if we can kind of figure out what's going on. So it says it's a weighted average of the mass at each location. So you guys actually do weighted average calculations all the time, you just don't know it. So when you're trying to figure out your grade for a particular course, you might have, say, like tests worth a certain amount, assignments worth a certain amount, culminating's worth a certain amount. Okay, they all have different weights associated with them. Okay, well the same thing is happening here, right? We have x coordinates with a specific weight to them, the weight being the actual mass of the planet, right? So if you see here, what we have is these coordinates here, so the 20, the 45, and the 80, that's the x values of your positions for each of the different planets, and see how they're multiplied by 50, 20, and 60. Well, that is the mass of each of the planets. Okay, and then since it's an average, you are multiplying by the, you're dividing by the total sum, right, of all the weights. Okay, so if you're thinking, like from a grade point of view, right? So you have certain things that add to 100, you end up dividing by 100, or whatever the total amount of marks that you were supposed to earn with. So if you had like 30% culminating, and you got 20% on it, which is really bad, but you'd take your 50 and you'd take your weight of the culminating multiplied by what you got on it, and then you would add up all the other weights with them and then divide by the total amount of marks in the course, which would have been 100. Okay, so it's just a weighted average of what's going on. So this is actually a pretty easy calculation now that it's in a list, because so let's just take a look how we could do this from a list and a loop point of view here, because we don't necessarily know how many times we have to do these calculations. But what it is, we will have a certain amount of values in our list, right? And it's always the m list multiplied by the x list for the x variable. For the y variable, it would be the m value multiplied by the y, right? And for the z variable, it would be the m multiplied by the z. But you're multiplying by the same index location, right? Like you're taking the first mass, multiplying it by the first x, the second mass, multiplying it by the second x, and the third mass multiplied by the third x. So the weighted sum is just going to be the just the two lists multiplied together inside a loop, and I've got to do that 3 times. So I think might as well just write a function that does that. So let's write a function that will do the top calculation, and then a function to do the bottom calculation, which is the sum of the weights. Well, those are easy. Okay, so we'll go back to the IDE, and we can kind of figure that out. So I'm going to need 2 functions, one that just sums the value of a list, and the other one that sums the multiplication of 2 lists. That's what we'll do. And then I can apply that second function to all 3 of my for all 3 of my coordinates. Okay, so we'll start with so these are my functions needed. Okay, so we'll do the first one, maybe called sum list. I mean, sum list. Okay, and this is just a general function that is going to add up the value in any list. So we could say my list as the argument, and we know how to do this. We've done it before. I suppose I could use the short form for it, but let's just write it out so we can practice the algorithm. So from 0 to the length of the list, and your total would equal to your previous total plus the value in the list. Okay. I don't always like to use the necessarily built-in Python functions all of the time, because I'm hoping that you get some skills here that you can apply for many different programming languages. And say Java doesn't necessarily have a function that just adds up all the values in an array, or C or something like that. So it's good to know and get practice writing out kind of the base algorithm sometimes. And we can return the total. Okay, so that will just add up the values in the list. in a list. So that'll be good for finding the total mass of the planet. Okay, and then if we want to do the weighted sum, we need two lists, right? So we'll need list 1 and we'll need list 2, and we can add that up too. I suppose I could probably use this function, but it doesn't matter. So I'll start my total at 0 and range from 0 to the length. Now, both of these lists will have the same length, so I'm just going to pick list 1. And my total would be my total plus the list 1 times the list 2 at I. Okay, so that is going to be a weighted sum of the values in two lists. And we can return the total. So how I would use that then is, so once I have all the data, I'm going to find the weighted sum of all the masses. So my x coordinate would be, actually let's do the top. We need the numerator, right? So maybe we'll call that like total x. So it would be weighted sum of m and x. Okay, so we'll send m and x to that function to do the top number, or so like this top calculation here. Okay, and then we'll do the same thing for the total y, which would be weighted sum of just m and y. Okay, and then our total z would be the weighted sum of m and z. Okay, so that's going to get the numerator for all of those values. Right? So this is, I guess, what would you call that? This would be the total mass at each coordinate. Okay, and then I need to find the total mass of the solar system. Okay, so total mass, so that would just be my, what did I call it? Sum list. Okay, sum list of m. Okay, and now my coordinates would be, so my x coordinate would be the total x value divided by the total mass value. Okay, my y coordinate would equal my total y value divided by my total mass, and my z coordinate would be my total z divided by my total mass. Okay, and then I have to print it out in the correct format. So it shows the total mass of the solar system and then the 3 coordinates. It looks like it's rounding it to 1 decimal spot. So I suppose I could round each one of those to 1 decimal spot. Okay, and we'll print out the answer. So what do I need to do? Print total m. Oops. So that's the, and then I need a comma, and then the x coordinate, comma, y coordinate, comma, and then the z coordinate. And nothing after that. Okay, so I think that would work properly. Okay? And we can see. So 3 planets, and let's see all the data in here correctly. Probably should have tested those out ahead of time, but video was running a bit long here. So what do we have? We have 50, 20, 60, 100, 20, 45, 5, and 15, and 60, 80, 40, and 55, and that is, I believe, the same as my sample output. Okay. So, what did we learn here other than how to do kind of a more complicated problem? Well, break your problem up into pieces. Okay, that is the biggest idea here, right? If you can write functions to solve some of that problem, then write functions to solve part of the problem. It makes your code cleaner. It makes it easy to read. In this case, we're able to reuse a function a couple times so that I didn't have to rewrite that code several times, and it just makes it really easy to read what you're doing. Okay, so take your time, write the code in pieces, plan it out, write some functions if you think it's worth it, and try to solve the problem.